come in. So welcome to our septic systems best practices in maintenance and repair workshop, where we're going to talk all about water quality, septic systems, and then connect that to watersheds and the work that I do as the Currys Fork Watershed Coordinator with Oldham County Fiscal Court. And then we also have our septic system cost share program, which we're going to talk about, and attending this workshop is required for you to be eligible for financial assistance. I also have the pleasure of working with Charlie Ward, who is the environmental director with the Oldham County Health Department. So beyond this workshop, if you end up applying for the program and then being part of this process to repair your septic system, you're going to work with both myself and Charlie. Anything to add, Charlie, before we get started?
Nope, that all sounds good.
And I expect this to take the full hour and a half. I appreciate everyone taking time on this beautiful Monday, especially after last week, but this is really important and we're glad that you are here. Okay, so just to get us started here, thinking about our septic systems, I'm going to launch this poll. And we want to know, when was the last time you had a septic system pump out? So we're looking at between anytime in the last 12 months to maybe more than 12 years ago, or maybe you're not sure. And then if you haven't done so already, please put your name in the chat box so we can make sure you're accounted for. Got almost everybody in. I think you're going to like these numbers, Charlie. All right, everyone's in. Awesome. So we've got most people within the last 5 years, and actually quite a few in the last 12 months. So maybe that means that you're already on top of it with your septic system, or maybe you have an issue and the first step was to get a pump out and you're here because you have an issue and you want to receive some financial assistance. So I guess we'll find out as we go through this process. And Charlie, I see you're shaking your head. Okay, let me get rid of that. So who is our audience here tonight? Well, septic system owners, of course, and we're especially looking to target those with improperly functioning septic systems, but anyone who has a septic system and either needs to know or is interested in septic system management is welcome, and will hopefully gain a lot from participating in this workshop. I just want to lay out some expectations that you should have for this workshop. I think you should expect to learn about the connection between watersheds, streams, and septic systems. To learn about the actions that you can take to improve local waterways and minimize damaging pollutants. To learn the best practices for septic system maintenance. To learn about local resources available to you. To broaden your understanding of your part in helping the environment. And you should expect that the information today is rooted in sound science and given by local professionals with extensive experience in the field. And a quick overview. So I'm going to start off talking about water quality. It's going to be kind of an introduction or a primer on that. And then Charlie's going to take over from there and talk all about septic systems, maintenance, what is a septic system, and so forth. And then I'm going to take it back and I'm going to talk about our septic cost share program, and then next steps if you're interested in applying for our septic system cost share program. And then we'll have our pump out giveaway. So 2 people here tonight are eligible for a free pump out. And since many of you have gotten one recently, we'll just have to figure out what makes sense with that based on our winners. Okay, and just a reminder, so I am the watershed coordinator. I specifically focus on the Currys Fork Watershed. which we'll get into later, and I work for Oldham County Fiscal Court, and Charlie Ward, who is the Environmental Health Director at the Oldham County Health Department. All right, so introduction to water quality, and we're gonna focus on this through the lens of the Curry's Fork Watershed program, which is the program that I manage through Oldham County Fiscal Court. Okay, so just to kind of get us all on the same page here, thinking about the water cycle. So water goes through different phases in the environment, but there's always a set amount of water. So this is something that we're all, you recall this or you're very familiar with this. We have typically in our area in Kentucky, we're most focused on precipitation, although sometimes we do have snow. Transpiration, that's where we have vegetation, especially trees that emit that moisture back into the atmosphere directly. We have evapotranspiration from our lakes and surface waters, and that goes into this cycle. And one piece of this that isn't shown, really pointed out as well as it should be, is our groundwater. So our water infiltrates into the ground, and that makes it to the groundwater, which is really important for water storage and water availability, as well as filtering out any pollutants that make it to the groundwater. Make it to the streams. And we kind of know this, but just a reminder that we don't have a lot of water on Earth that is accessible to us for drinking. So most of the water is in the oceans, which means that most of it is salt water, it's saline. And then from there, we have this 2.5% of our total water on this planet that's fresh water. That's split between groundwater, glaciers, and ice caps. This is from 1993, so this might not be accurate today, but just to get a sense for the point of where in general our water is and how much is available to us. And then from there, we're looking at our surface water and our other fresh waters. And we really only have this little bit amount, this 0.49% of that 1.2% of that 2.5% that's in rivers. So just knowing that we really don't have a lot of water that's contained within our rivers, but our streams and rivers are really important for us. And I'm going to talk a little bit more about that. So when we talk about streams and rivers, we're talking about a body of flowing water. So by definition, a stream is a flowing body of water. And we find our streams at this intersection of the Earth's surface with the groundwater. And this generally indicates that there is areas where the water is flowing downhill. So when we start to kind of think about our environment and our landscape, we're really focused on our topography. If we're uphill of something or downhill of something, that's going to mean some different things. But we're finding our streams in our valleys, in the downhill areas, and everything that happens uphill in that area leads downhill, which starts to get into us thinking about watersheds, which I'm going to get into as well. So thinking more about our streams, we have what we call ecosystem services. So these services that nature provides to us. And there's a lot of these, and we often forget how important our streams are. So our streams, they help to dissipate energy for flood control. If you have a space where water can go to that it's meant to go to, such as our streams, then it's not going to get into our cities, our neighborhoods, our communities. Wetlands. Now, Kentucky doesn't have a whole lot of wetlands, but wetlands are really, really important for water holding capacity, for infiltration. They help to filter nutrients, and they also help to hold water on the landscape instead of having it go directly to the stream and then flow away from where we might need it. They help sequester sediment. So sediments, which is really just a term for saying our soil or dirt, is the #1 pollutant in Kentucky. So when we think about sediment, when we think about erosion, it's not a minor issue. It's actually a very big problem and something we're really focused on trying to address. And then from there, habitat. Aesthetics, of course, we really enjoy nature. And then again, that releasing that water into further down the stream. So our wetlands, our tributaries, our smaller streams are all really important and provide this network that provides overall these really important ecosystem services. Okay, keeping on this train of benefits we receive from nature. So whether we spent a lot of time really digging into this or understanding this, the science is there, and we really know how important nature is for us, not just for these environmental controls and flood protection, stormwater management. Those are really important, but also in terms of our well-being, our physical health, our mental health. There's so much importance there as that connects us to nature, and being, in a park or seeing a tree out in front of, our office window, that's going to provide benefits that we wouldn't receive if that weren't the case. So talking about these ecosystem services, these benefits, this importance we have with nature, we're out of balance, and this starts to get into, well, what's going on? Why are we seeing, maybe the issues on our landscape, pollution? What's happening in very broad terms is that we have this over-reliance on our ecosystems. We're asking more, we're taking more than the environment is able to provide. And this has put us out of balance with our environment, and we're not, all those services that we typically are able to provide, well, we're not receiving those as much as we need to be and we'd like to be, because of this over-reliance and ultimately being out of balance. So in more extreme terms, this out of balance looks like this. It looks like flooding, sea level rise, forest fires, massive amounts of trash, pollutants. This picture down in the corner here is actually a trash island in Louisville on the Ohio River. Flooding, that's something that, well, maybe we don't see flooding like this, but we have pretty serious flooding in Kentucky. And then loss of our bird species and other wildlife. We're really noticing that we're not getting the abundance of species that we used to. So these are sort of the big things. And then there's a lot of small things too. So thinking about what we're seeing locally is more like this. We do have some more extreme events, but it's these little ones around here that are really adding up as a result of this over-reliance on our environment. So problems we're finding locally, broadly speaking, pollution, flooding, erosion, loss of land, reduced habitat for wildlife, algae blooms, which sometimes are okay, but they can be harmful. And then ultimately excess levels of bacteria, which is going to connect us into our septic system issues. And when we say excess levels of bacteria, that means there's some effluent of some kind getting into our streams. Now, where is it coming from? Well, that's a harder question to answer. We know that failing septic systems are a problem. We also know that agriculture, dog waste is a problem. Deer, even in wildlife, can be a problem. So there's all these different pieces, but we can only control so much of this. So focusing on septic systems, well, that's something that we can control. And through this workshop and this process, we're trying to do that. And then just a few more pictures just showing, what does the accumulation of these problems look like? And I focus a lot on streams. If you don't live near a stream or you haven't been near one recently, I highly recommend you find one and you get out and you see what they look like. Sometimes streams look like this in the top left, where I was mentioned sediment. They're totally brown. They were just full of sediment. Sometimes we have banks that are completely vertical, where the stream clearly wasn't here before when this pole was installed. Sometimes our streams are completely blocked. You can't even tell hardly that there's a stream behind this blockage. Algae blooms I mentioned, tree roots exposed. So all these somewhat minor, somewhat major problems that we're noticing in our streams, and then thinking about, well, where is this coming from? And just listing again those different types of pollution. I'm in this field, so sometimes I forget that pollution really needs to be identified. Well, what is pollution? So just laying it all out there where, we have sediment, fertilizers, and nutrients, total dissolved solids. So anything that's not a liquid that's somehow getting into the stream, bacteria, pathogens, pesticides, herbicides, trash, litter, temperature. So temperature is a big problem because our fish don't want to be in a hot tub. So it's considered pollution when you have a hot water or even some type of other warm liquid that's mixing with the stream and raising the temperature. Metals, oil, gas. So there's a lot of different things to just wrap our minds around when we're thinking about pollution. And then I just wanted to show this picture. I took this today, and we're finding this a lot where our streams are full of this really bright green algae. And my guess is that what's happening is spring happened, right? And so a lot of people are starting to put fertilizers on their lawns. And we had that big rain last week, so a lot of that probably washed off, and now that excess amount of fertilizer has ended up in our streams. And one of the fun parts about my job, but also one of the really challenging, is that we see these problems in the stream and we know they're a concern, but actually identifying where they're coming from is a challenge. So not only where they're coming from on the landscape, but what's causing them. And this is all tied into our non-point source pollution, which is just pollution that we can't really exactly pinpoint. So several lawns having fertilizer and that fertilizer all washing off is a really good example of non-point source pollution. Okay, so thinking a little more broadly about what's causing these issues like erosion, flooding, and land loss, we need to think about how what our land looks like, what the surface of our land is doing. So, and this is where I have the question of infiltration or runoff. So this top part here, if our land is covered in natural vegetation, trees, that's where when we have a rain, a lot of that water is able to infiltrate into the land. I mentioned the importance of groundwater and water infiltrating and connecting to that groundwater. But what happens as we add impervious surfaces we add driveways, parking lots, any hard surface, even lawns are really considered a hard surface. A lot of the time we lose that infiltration capacity. And when that water can't infiltrate into the ground, it has to run off. So if you haven't heard that term runoff, that's just what that means. It's that precipitation that hits the ground, and instead of infiltrating, it has to flow. And it's going to flow downhill. And we know that if it flows downhill, it's going to end up in our streams. So now we have water that is not able to infiltrate. And if there are pollutants that water collects, it's not the soil and the ground isn't able to pull out those pollutants. They just get picked up by the runoff, and then that flows and collects and accumulates down to the stream. Okay, so a piece of this too is we have what we consider our typical lawn versus our beneficial lawn. So the number one cause of species decline is really habitat loss. There's a lot of other pieces to that as well, but habitat loss is just the idea that we've lost the habitat, the shelter, the space for reproduction, the space for growing the food that the wildlife need to eat. We've just lost that, and then without that, you don't have that abundance of wildlife. Okay. Thinking about our lawns this is a really big topic because we have this idea of what we want our lawns to look like. Sometimes there's even laws that say kind of how we have to manage our lawn. But I encourage us all to sort of take a step back and rethink the purpose of our lawns and think about maybe doing something that would help our lawns to be a little bit more beneficial to this bigger idea of getting back in balance with nature. So when we think about our lawns from an ecological perspective, we consider them to really be a monoculture. There's usually not very many species growing among our lawns. And they're also basically considered sterile. So for basic biology, for a plant to reproduce, it has to go to, like if it's a grass, it has to go to seed. But when we cut our lawns, we're stopping, we're literally cutting off the cycle where the grass can't go to seed, there's no reproduction. And wildlife rely on that seed, the plant relies on that seed to grow and spread. So it's really just creating this sterile environment all around our properties. And the other piece of that I mentioned before is that our lawns are very compacted. So not only are they not great for wildlife, but they also are not great for infiltration. And you can look up different videos and see different how when you put water on lawn compared to putting water on an area that has native plants or trees or deep roots in the ground, you really get this drastic difference of how much water is just running off. And you've probably seen this in your yard too, is that water is more likely than not to just run off your lawn. But we really want to build up that infiltration capacity. So thinking about on this right side, changing a little bit of how we manage our lawns and adding in different plants, specifically native plants, maybe letting our lawns grow a little taller, creating fertile landscapes, which ultimately lead to creating healthy soils. Okay, so just kind of putting this together a little bit more, kind of this piece of how we function on the landscape, how we have changed our landscape, and then ultimately how that impacts the streams. So that's sort of this, it's this cycle here where when developments are built, all of the topsoil is removed. And that topsoil, that's really where that's where life is. That's where things grow. But when you go and you build either development or really anything, typically what happens is to flatten the ground, to put up a structure, you remove that top piece. Okay. And then from there, not only have you removed that topsoil, but now you're increasing your impervious surfaces. Part of this process of development is also what goes on is we remove, we reduce, and we alter our small waterways. So thinking about how streams have changed, well, in the past, there was just way more streams. There was way more waterways, and most of the waterways were small. But just because, you know, we need to urbanize, we need to fit everybody, it's the process of expansion, we've lost those waterways. And then byproduct of reducing those waterways and adding the impervious surfaces, losing our infiltration capacity, now we are sending just a lot more water to our streams, and our streams are not able to handle that increase in load of all of that water. So then we get our stream bank erosion. Sorry. Then we get our stream bank erosion, and then if you don't have your stream banks intact, now you've lost that habitat, that really essential habitat. And then on top of that, all that water going to the streams as runoff has increased the pollutant loads going to the streams. So I just want to make sure that as you're thinking about sort of one piece of this puzzle, understanding that it's really all connected, which is both a challenge and a positive, because that means if you take an action to do one good thing, you're probably impacting this whole cycle in a positive way. Okay. So water quality in Kentucky. Problems with air quality and water quality have been noticed for a long time now. And if you were around in the 1970s, you may have experienced this yourself with rivers on fire, intense smog in LA, other issues. So Congress took a step back and said, we have to do something about this. And that's where the creation of the Clean Water Act of 1972 came in. And what the Clean Water Act said was that to eliminate discharge of pollutants into navigable waters by 1985. Now, that was the goal. Did it happen? No, but that was the intent of it. Okay, and the second part of this was to achieve water quality, which provides for protection and propagation of fish and wildlife, as well as recreation in and on the water by 1983. So these were really, really great goals. And did they happen again? No, they didn't. But we're still working on this, and we're still working with the intent of we want our streams to provide habitat for fish and wildlife, and we want to be able to recreate in our streams. The third part of this was that the Water Quality Act prohibited discharge of toxic pollutants in toxic amounts. So that's a big part of that, where they have to determine, well, what is the toxic amount? What is our toxic pollutants? And if you pay attention to EPA, their whole process for this, if you know anything about that, it's a long process to really figure this stuff out, and they're still working on it. So here in Kentucky, the Kentucky Division of Water is who manages the Clean Water Act for Kentucky. So they manage these pollution sources. They're tasked with the regulation of point source discharges, which is where you'd have a pipe or some form of something you can identify that's polluting the stream. So I'd mentioned those non-point sources, for example, fertilizers, where you can't really pinpoint where it's coming from. That's a non-point source. A point source is where you can point to a pipe, see that pipe discharging into the stream, and you can regulate it. So the point sources get regulated, the non-point sources do not. The Kentucky Division of Water supports reduction of non-point sources, and they regulate those point sources. They also monitor the state's waterways, and they can determine if waterways are meeting water quality standards. So when we talk about water quality standards, we're talking about the ability for our waterways to be both swimmable, fishable, and to support aquatic life. And this is just a really neat image here. So Kentucky has over 90,000 stream miles, more miles of running water than any other state except Alaska. And I mentioned that the Division of Water assesses the streams in Kentucky, but the Division of Water is only assessing a small portion of the total streams. So I'm going to show you next more about identifying if our streams are meeting those water quality standards set by the EPA. But keep in mind that we're only looking at a subset of those streams, and we're looking at the most major streams, but there's still a lot of streams out there that never have eyes in them. They never get monitored, and there's a lot of unknowns out there. So determining if our streams are meeting water quality standards, I just wanted to show you this key real quick. I'm getting into the next portion here. So we want to know if our streams are healthy. Can you go into the streams and swim? Can you put your head under the water, and is that safe to do so? Can you recreate in those streams? Can you boat? Can you fish? Can you interact with the water where maybe you're touching it, but you're not actually submerging your head, so you don't have that risk? And then do our streams support aquatic wildlife? And there's a few others in here too, source water protection and fish consumption. We basically only focus right now in Kentucky on the swimmable, the fishable, and then the aquatic wildlife. And I just wanted to show that of those streams, those 15% that Kentucky Division of Water monitors, thinking about, do our streams support us going in them and swimming? If you stuck your head under the water, do we consider that safe? Is there a risk there? And what the Division of Water has determined that almost 80% of those streams that they've monitored, there is a potential risk of high levels of bacteria, and it might not be a good idea to stick your head under the water, maybe to let your kids go out and play, to let your dog swim. So it's not a small amount of concern, connecting back to all of these issues of pollution and the way that we're treating the landscape. So looking at Oldham County and what's going on, so on the previous slide, I'll just show again, you'll see that these impaired streams are everywhere throughout the whole state. But we're gonna focus on Oldham County and then the Curry's Fork watershed. So currently in Oldham County, and in this color coding, it's intuitive, where the red does not meet water quality standards, the yellow is potential risk, and then the green does meet water quality standards. So we've got a mix here in Oldham County. And these streams that are in, excuse me, the red here, these are the streams in the Curry's Fork watershed, which is the watershed that I work on. And in this Curry's Fork watershed, we have these several streams. All of them are impaired, meaning all of them do not meet water quality standards to some extent. So we know that they might not be safe to swim in, they might not be safe to fish in, and they might not support aquatic life. So again, the Curry's Fork watershed, when I talk about the Curry's Fork watershed program, why are we focused on this watershed and these streams? It's because these are the streams in Oldham County that don't meet water quality standard, and we are concerned about them, and we are working to repair them, and hopefully, ultimately, the goal is to get them up to par, meeting water quality standards. And just a quick reminder what a watershed is. A watershed is just the area of land that drains to a particular point along a stream. So when we talk about what's happening uphill in the landscape, that runoff that goes downhill and makes it to the stream, well, if you're in a watershed, that means that all of that runoff from that piece of land made it to the same point in that stream. So important to this is that you are always in a watershed, and they're kind of like Russian nesting dolls, where you have one and then another and then another. So it's just based on the scale that you're trying to study something or assess. There's different scales mean different things. So we're focused on the streams in the Curry's Fork watershed, but if I was focused on the Mississippi River, then I would be focused on the Mississippi River Basin, which is a larger watershed that contains several states and several smaller watersheds. And I assume most of you are probably in the Curry's Fork watershed, but just to get another visual here, there are 12 watersheds which fall at least partially in Oldham County. So watersheds follow topography, they don't follow political boundaries. But the Curry's Fork watershed, which is this brown one in the center here, is completely within Oldham County, which is helpful in terms of our work. And just another visual there of Oldham County and the Curry's Fork. And then mentioning those watersheds as Russian nesting dolls. Well, if we want to get on even a closer up look to watersheds within the Curry's Fork watersheds, there are 4 what we call sub-watersheds. So the Division of Water identified a long time ago that there are issues in the Curry's Fork watershed. And in 2004, long before I started with the program, Oldham County Fiscal Court started the Curry's Fork program. And part of this was creating a watershed plan. This is a U.S. Environmental Protection Agency approved plan, and involved several years of data collection, input from stakeholders, agency officials, the community, identification of pollution sources, identifying solutions to address the water quality issues, and then prioritizing the issues. So in my position as watershed coordinator, the watershed plan is my guidebook and is the justification for the work that we're doing, including the septic system program. And I just wanted to point out as well that I say unfortunately because I think these programs are needed and should exist everywhere. But this program through Oldham County and we work directly with the Division of Water. It's a very unique program. There's only 18 watersheds like the Curry's Fork watershed in Kentucky that have a watershed plan, and I'm sorry, 18 areas. If you look at this whole state here, that's really not a lot. But if you recall back to that map of impairments, there were a lot more impairments than specific watershed planning areas being addressed through the Kentucky Division of Water. And a little bit more about those pollutants. So I talked about, the pollution at the beginning, kind of the broad view of that. So for the Curry's Fork watershed, in developing that watershed plan, the pollutants were identified. So not just broadly that there's that septic systems are contributing bacteria to the streams, but where in the watershed are we likely to have those failing septic systems, and trying to build those same connections with all of these different pollutants and identifying their suspected sources. And then that connects back to our water quality impairments of this primary contact recreation, which is when we're saying, is it safe to swim in the water? And what's contributing to us saying that, no, it might not be safe to swim in the water. The same thing for aquatic habitat, us saying that our streams don't support that aquatic habitat. Well, what's causing that, and where is that pollution coming from? So the watershed plan, I don't have it in front of me to kind of show you, but it's a huge document that really digs into all this and provides a great resource for information. And then most importantly, it provides solutions. So these solutions are broken up into these main initiatives of education and outreach, stream restoration and stream buffers, on-site wastewater, green infrastructure, stormwater management, and then land conservation and protection. So this is a multifaceted plan that we're trying to really hit at all angles. And of course, here tonight, this program is part of our on-site wastewater septic initiative. So the Curry's Fork Watershed Plan, continuing on, why we're here, based on identifying bacteria in our streams, connecting that to failing septic systems. Well, where in the watershed are we finding failing septic systems? We have this priority area. So in the outreach for this program, it was mentioned to be eligible for funding, we have priority areas that we're focused on. And that stems back to that watershed plan, that data collected, and compiling that to understand, well, if we fix septic systems, we want to fix them in the place that's going to have the most impact for improving water quality. So we have this map here that I refer to say where are the highest priorities. And I think I've circled it here. No, not that one. I think in a later slide when I talk about it more. I'll talk about this more in this later on when we talk about the septic system program. But just understanding kind of the background of when I say priority areas, what do I mean? This isn't, arbitrary in determining where we're saying, you're eligible to have your septic system repaired through this funding. And then a little more background on the Curry's Fork Watershed Program, and then I think I have one more slide. So again, this program is managed by Oldham County Fiscal Court. Our goal of improving the streams in the Curry's Fork Watershed. It started in 2005. It's a very unique program, and they maintain a designated watershed coordinator, myself, and I work in the Oldham County Engineer's Office. This is a huge collaboration with government agencies, organizations, businesses, and residents, such as yourselves. And projects are driven by that Curry's Fork Watershed Plan, as well as by stakeholder input and public interest. And then I talked about a lot of our issues, but thinking about actions for homeowners, And all our solutions that we have in our watershed plan, everything requires public participation and buy-in. With this not an isolated effort, and we can't do it without the interest and participation of people. So part of getting that buy-in and participation is having the education so people are aware of what's going on, as well as providing some type of incentive. So financial assistance, giveaways, cost share, and anything else that really creates a partnership and understanding and makes things accessible to people. I just wanted to identify that there are other programs that we have that I invite you to participate in. We also have a local watershed group, Friends of Curry's Fork. And I didn't put it here. The best way to find information is on our Facebook page. And all of this will be sent out later. This best practices for landowners is kind of like a quick how-to guide for what you can do if you manage property in terms of water conservation, water quality, and plantings. And I lied, I have one more section here I added today. I know this is a lot of words. In case you want to take a snip of this, like a screenshot of this, but I just wanted to add in here native plants and your septic system. So I was talking with Charlie about this today because native plants are really essential and really important. And I was thinking, you know, could we get native plants on our drain fields, and would that be beneficial? So we just want to make sure that if we're planting on our drain fields, we're not planting anything that's going to have deep roots. Trees and shrubs are a no-go. You don't want water-loving plants, because if you plant something that wants water, it's going to send roots deeper down. And then the problem is that if the roots wrap around your pipes, then that causes problems. So we want to avoid that. But there are plants that don't have super deep roots. They aren't water loving, so they're not going to send those roots deep down and try to find that water in your pipes. That are native plants that have those benefits of helping wildlife and all of these other benefits that I've mentioned here today. So if this interests you, let's talk about this more. I'd really love to see this happen on some properties, and I just wanted to make sure I point this out. And I kind of talked about this too, just benefits of native plants in terms of wildlife, erosion control, and ultimately resilience, and really connecting back to getting us back in balance with nature. Okay, so I think I'm going to forego questions for now, and I'm going to turn it over to Charlie. But if you have questions, you can put them in the chat. And we'll have time for questions at the end. If you think you're going to forget, definitely just write it in the chat. And I'm going to stop sharing my screen because I definitely want to make sure we get out of here by 8 o'clock, or try our best to. And I'm going to turn it over to Charlie if you're ready. And again, Charlie Ward is the Oldham County Environmental Director for the Health Department.
That covers that up. All right. So Becca, you're able to see the gray screen?
Yep. Mm-hmm.
Okay. All right. Well, yes, everyone, my name is Charles Ward. I am here at the Oldham County Health Department, the Environmental Health Director. Just to get out of the way, if anybody hasn't had their COVID vaccination, we still have appointments open for tomorrow. If you would like to get it, we do have it available as well. But to get into what should be the majority of my job when I'm not dealing with pandemics, is the on-site sewage program here in the county itself. Just to go over kind of some introductions of what basically on-site sewage wastewater treatment is. The idea is that in all of our wastewater we're producing, there's a lot of bacteria, viruses, parasites, things that need to be kind of denatured and taken care of before we're introducing things back into the groundwater. The idea being now is that we are using a tremendous amount more of water these days between toilets, showers, laundries. We have started using some water restricting devices and low flow toilets, which is helping with it. But at the end of the day, there are several hundreds of gallons of wastewater that'll be produced that we need to find a way to get rid of. and doing a specific on-site wastewater treatment with that on your individual property was the solution that we're coming up with. So just to kind of go over the on-site wastewater treatment, basically it's just a cost-effective means of getting rid of your wastewater on your property versus large-scale municipal sewer treatment plants. Treatment plants are great because they're in a large source. Hold on one second, I have someone at my window. Oh, I'm doing my presentation. Get out of here. Okay. And that basically that the cost of large municipal plants versus individual septic system can be rather grand, but an individual system on a one person's property can be rather cost-effective means. Instead of trying to treat millions of gallons of water a day, you can just treat several hundred gallons of water yourself. The big idea with on-site wastewater treatment is that you're using the soil and the natural properties of that soil and the bacteria to clean up and disinfect your wastewater before you're ultimately returning it back down into the groundwater. Like Becca was saying, basically water is created, it's used, and then it's reused. The idea is that you've collected this water, you've now used it through your house, and now you need to reintroduce it back into the ecosystem so that way it can be recycled and recharged again in the future. So what is the soil doing? So soil itself is usually made up of three parts. It's sand, silt, clay, and the fourth being loam. Loam is just something where it's a combination of one of the three. When it comes to soil, it's all about the soil particle size, where think of granular sugar and powdered sugar. That one is larger and greater than the other, but one is very fine, where that granular sugar is more like sand and clay is a very, very fine particle. The idea is that sand is a great filter, but clay is an even better filter, but because of the small porosity size of clay, it's a very slow filter. And that actually what was kind of thought of was that most of the breakdown and the bacteria is taking place beneath the soil of the lateral field, not exactly above it, and that it's the soil and its bacteria breaking down that wastewater over time as it starts to percolate through the soil beneath it. So it also talks about how the soil, it absorbs and inactivates the smaller organisms such as viruses. That is kind of one of the concern now. There was some studies done with MSD in Louisville talking about how they were kind of checking for COVID in wastewater, that it could be passed along, but that's like other diseases, be it hepatitis, E. coli, fecal coliforms in general, just something very bad that we need to concern ourselves as far as with contamination that goes for it. So big idea with onsite though is basically protecting that wastewater, protecting the groundwater from the wastewater and infiltration and make sure you're removing all those contaminations. And again, so it talks about, so it's commonly believed that soil absorption is evaporation, but it's actually closer to 5 to 10% of effluent is being removed by evapotranspiration. That's the idea that the grass or the native plants above it is taking up that wastewater and then throwing it back up to the atmosphere, where actually it's more like that the wastewater is traveling down vertically into the ground, and then it's being reabsorbed into the underground aquifers as well. So just some wastewater basics, just some terminology itself. So the wastewater itself is just, again, it's anything that's going down your sewers and your drains. It's just the pathogens, the salts, the fats, the oils, the grease. There's a definition of black water, and the difference between black water and gray water, other than what you can see there, is the strength of the effluent that's being produced when it comes to bacteria load itself. That your toilet and your kitchen sink has a lot of organic matter going down it from your waste that you produce, and then other things going down your kitchen sink from, say if you're utilizing a garbage disposal and it's cherry pits or strawberry pits and potato skins and things like that. Gray water being your laundry line, showers, and just regular hand sinks. There's a lot of water that's with there, but a little soap, but very little pathogen load that's going through it. The biomat is the actual bacteria and the microorganisms that are created in your lateral line itself, where over time, as this effluent is slowly filling your lateral field, this biomat will develop in the bottom of the lateral field. And it gets to be this kind of, call it thick, spongy layer of bacteria, because the bacteria is just growing and proliferating and feeding off of that wastewater over time. And that's kind of ultimately what leads to one of the failures of a septic system, is a biomat that develops too thick and too heavy over there. The septic tank is just a vessel that's retaining solids. Normal conventional septic tank is anaerobic treatment, and that anaerobic is without oxygen. There are other types of septic systems that are called advanced treatment units that use aerobic digestion units, where it is basically air and oxygen is blown into a tank to agitate it to create more beneficial bacteria to further break down that organic waste. And then of course you have your lateral field. That's where the treatment and disposal of effluent takes place out on the property after it exits the septic tank. The treatment, again, we talked about, it's the biological process of taking your effluent from your sanitary sewers and discharging it down to the environment and using the soil as a filtration of pathogens. And then again, the fancy word being either evapotranspiration, or I have seen it as evapotranspiration, as a portion of that wastewater that is going up into the atmosphere versus down into the ground. So just to kind of start through the installation process of an on-site wastewater treatment system. First thing, again, you'll get myself or one of the environmentalists here from the health department. We'll come out and make a site visit to the property based upon certain factors of soil types, topography, location of certain structures like driveways, utilities. We'll meet with the homeowner and then the designer or the installer of the septic system and kind of determine, okay, what are some of the limitations and availabilities we have on this property? And based upon taking some soil borings or digging some backhoe pits to determine, okay, here's the soil in this area and what depth can ultimately the system be installed at. And this is just whoever's involved in the watershed program. If you do have me make a site visit out to your property, ultimately you will end up with one of these. This would be the information that you would give to your installer as kind of the laundry list of the ifs and what needs to be done in order to do a repair on the septic system itself. So you will get a write-up from me. So there's not like, well, what did he say? What do we have to do? It will all be written down and typed out. So that way you can pass it along to those that'll need it. So in doing the site evaluation, like I said, there's many factors. Doing the landscape position, we want to make sure we're not putting a lateral field in any kind of drainage ditches. We're not close to any creeks or streams, that we're meeting certain setback distances from the house. One of the big thing is with a lateral field, you are artificially watering the ground beneath that system. And you want to make sure that there isn't any other groundwater or any other kind of wet areas that can infiltrate this area and offset the amount of wastewater that you're putting into the system as well. So this is just kind of a rough cross section of just the general process of how a septic system works. You have your house with your sewer coming out of it that goes to your septic tank. The septic tank being primary treatment is where your sewage comes into the tank and all of your fats, oils, and grease, which wants to float on the top, your heavy organic material that will settle on the bottom, and then you have that clear effluent layer in the middle, and that is what comes out of your septic tank is just effluent. It traps all the solids inside of it, and that's why you have to periodically pump your septic tank out, because that organic layer will build up over time. That bacteria in your tank can only break it down so far. And then ultimately it will have to be pumped out and removed manually as itself. And then you can see coming out of the septic tank, we have distribution box there'll be several of them. Sometimes there's just one, and I'll speak about those here in a second, that will lead to the lateral field. And then you're showing how we like to keep at least an 18-inch separation distance from the bottom of your lateral field to any restrictive horizon. Those can be massive clay, rock, groundwater, any number of factors. But the idea being is we need at least 18 inches of soil beneath that system as the filtration unit in order to clean up that wastewater before it turns back into the groundwater aquifer as well. So just to go over the septic tank, some of them are rectangular. There are some round kind of pumpkin style ones. Mainly it's just that there is a standard unit that is described where you have to have the number of bedrooms that's in a house, and then you multiply it by a total daily waste flow, which is as of now 110 gallons per day. Is what they're saying predictions that per bedroom you will create 110 gallons of wastewater per day. Sized upon that, there's tanks range from 1,000 gallons up to 2,000 gallons. It's basically just a large vessel that will kind of slow down that sewage coming out of the house, let it settle out, and again, trap those organic solids in that tank, and then allow just that wastewater consisting of effluent to go out and drain into the lateral field. Inside the tank itself, there are tees, sanitary tees, or sometimes baffles. The next slide I'll have coming up will kind of show and explain how wastewater will come into your septic tank and how it's forced to separate and settle out, and then how it can carry out into the lateral field once the settling has taken place. There are some tanks that will have effluent filters on them, and this is just a kind of a secondary screening measure to make sure that there are no solids that carry out into your lateral field. Because I once had the little lady who bragged to me how she had never pumped her tank out, and her house was 40 years old. And I was like, man, that's nothing to be proud of. You probably have a lot of sewage and wastewater that's pushed all this organic solids out into your lateral field, creating problems for you. So periodic maintenance is something definitely needed. Here's just your typical single compartment septic tank. On the left side of the screen, you have the inlet coming from the house, and those two kind of T's that are on their sides, those are the sanitary T's referring about. So when what comes in on the left is flushed down, what wants to float will float, what wants to sink will sink, and that's where you'll develop that scum layer on top. That's where all the fats, the oils, the grease, everything that wants to float, your papers and things, those will float on the surface. Your sludge layer is down on the bottom. That is the heavy organic matter that's settling over time. And then you can see on the right side, there's the outlets. So once that tank is at its operating level, just that clarified layer of the effluent is only allowed to exit the tank as well. So that way you're not getting any kind of scum or anything floating across the top and exiting out the tank. A lot of you with having older septic systems, you might not have those risers on the top of your tanks and the kind of those green garbage can looking lids as well. That was a requirement in 2002 that surface access be required to all septic tanks. Those can be retrofitted onto your tanks. It's something where it's very convenient to have them, so you can easily point your finger to the ground and say, that's where my septic tank is. I know exactly where it's going on. Because a lot of times there could be 12 inches to almost 3 feet deep that these were buried, and a lot of people they have no idea where their septic system is because there's no distinguishing factors where you can see something on the ground that's visible access to it. The tanks themselves, usually the big three that we have are concrete, plastic, or fiberglass. Mainly right now it's concrete and plastic. At one point they were using coated steel tanks, and even further back in the day there were brick and mortar tanks that were used. Prior to the Onsite code existing, people just kind of used what they had and makeshift units of what they needed. Your septic tank, it must be watertight and have withstand hydrostatic pressures. The idea is that even though a tank being very large and full of water, there can be a certain amount of groundwater that's trying to push on the outside of that tank. Even a concrete tank will float out of the ground. I always explain to homeowners and installers that, look, a barge can float down the Ohio River and it's got several tons of coal sitting on it, but it still floats. The idea being, or the concern is that if there's any more water outside your tank than inside your tank, it will pop up and out of the ground. And then just to show you some basic designs, the one on the bottom left and the bottom right, those are both plastic tanks, and on the top of that tank is the concrete tank as well. And these are all single compartment anaerobic digestion units, not the more advanced treatment units that we sometimes use today. So again, just the functions of the tank, we talked about this, the scum, the liquid, and the sludge. It's basically making everything separate out from what gets flushed down your drains and making sure that we're only collecting that clear effluent layer where there's no suspended particulate matter that carries out into the lateral field. So when it comes to proper tank design, a lot of it is going to be dependent upon, again, the number of bedrooms in the house. You can take some time in consideration, say if it's just a 4-bedroom house, but it's a larger family that has many kids, you can oversize that tank. The idea being is that you don't want big surges or anything going through that tank where, say 5 people all took 15-minute showers back to back to back, there's a lot of turbulent water flowing through that tank. And if that tank isn't large enough, it can resuspend some of those solids. And that's the idea, is that you want that settling to kind of naturally occur through that tank and give those microorganisms a chance to break down that wastewater and really kind of settle it out. So again, we talk about the process of anaerobic digestion without oxygen. There are some things you can add to your tank as far as like brewer's yeast and other kind of good beneficial bugs. Honestly, there's enough bacteria colonies and what we shed in our own waste as humans to help populate and get that tank going and keeping it sustained. But if you ever did have your tank pumped out, you could throw something like brewer's yeast back and down your drains, and that will help get those microorganisms back going and repopulating the tank. This will talk about anaerobic treatment. Again, this is now adding oxygen and other air to your wastewater inside your tank. Basically, it's just once you add oxygen, you start getting even more beneficial bacteria. I kind of equate it to like a filtration with like a scrubbing unit inside your tank, where even though there's just a mechanical process of air being pumped through it, because of that oxygenation, it really breaks down the organic matter even further. So that way there's less bio load going out of your tank to that lateral field. So that way the microorganisms in the soil don't have as much of an increased burden to try to break down that wastewater even further. It's really been kind of scrubbed and cleaned even further before it ever gets to them. And then this is kind of just showing again, the single compartment tank. Just to kind of reiterate, wastewater coming in from the left, everything settling out in the middle, and then gray water carrying out to the right. And this will be your 2-compartment tank. The idea is that once you put another larger baffle in between those 2 tanks, or if you had 2 tanks connected in series, it allows for even further settling to occur, that you're getting that suspended solids to actually kind of settle out into the bottom of that tank. So there's even less risk of organic solids reaching that outlet pipe and carrying out to the lateral field, potentially clogging or blocking your lateral field. And this diagram of an advanced treatment unit, it's just showing basically that there's an aeration chamber where there's a motor that's basically either it's a paddle wheel or sometimes it's a snorkel unit where it's just somehow recirculating that wastewater to add that oxygen to the tank. And then it allows for a further settling chamber on the backside of that. So the concern with these units, though, is that it does resuspend some of the solid. As beneficial as it is to break down waste, it is resuspending it sometimes too. It's like taking a glass with some sand in it and stirring it up, and the sand, is floating through it, but over time it will settle back down. But aerobic treatment units were very popular back in the day. They are a mechanical process, and anything that's mechanical in our line of work is going to be broken down and have to be replaced at some point. So the conventional anaerobic treatment unit was kind of more favored and heavily used now. Some of us will have pump tanks. Basically, the idea is you have to have a pump tank because your lateral field's uphill and higher in elevation, and gravity is a constant, and there's no way to overcome it. Even my septic system myself, my lateral field is very low next to the house. My lateral field is up on the hill, probably 35, 40 feet in elevation and 60 to 80 yards away from the house. So you have to overcome that by having a pump tank. The pump tank, again, will be sized based upon the number of bedrooms that you have in your house. And there's a certain dosing that occurs with that tank, where that tank isn't completely full and then it's completely emptied. You always want to keep a certain level of effluent in that tank, because again, if it was empty, that runs the risk of popping out of the ground. If you overpumped your tank and then it rained the next day, again, it could float on you. It's usually dosed a couple hundred gallons whenever the pump kicks on. The idea is that there's a float switch that'll kick on. It pumps it up to the hill to where the water flow can take it, and then it completely shuts off. And then until that tank fills up again, that pump won't kick on as well. The idea is that you're dosing your system where it's getting a small amount over a period of time versus a gravity-fed system without a pump tank that's basically getting a little all the time. That as you use your water, and if you have a gravity system, that water is immediately, goes through the tank, settles out, and then goes right out to the lateral field. Where if it's a pump system, goes through your tank to this pump tank, and until that float switch kicks on and doses it to your lateral field, it's not doing much of anything. The concern being with the pump tank, yes, this is now another mechanical aspect. It is a pump that will burn up at some point, but with the code for the installation of pump tanks, an alarm is to be required, and then the alarm is to be set at 85% capacity. So if or when that pump does fail, there is an alarm that will go off that say, hey, your tank, you need some attention, your pump's burned out, you've got 15% left to use, which by calculation should be about 2 to 3 days to keep utilizing your sewage or your wastewater in the house before you have a problem of either wastewater backing up into the house or out onto the ground above the top of your septic tank or pump tank. And then this is just a cross section of the actual kind of the layout of a pump tank as well. You have the water coming in on the right. You have a series of float switches to turn the pump on, turn the pump off. You have the highest float switch is your high water alarm. And then at the top, you have the alarm itself. On this one, it looks like the alarm has been outside. With code, if it can be retrofitted inside the house with new installation, we will put an alarm in a high traffic area where it's an audio and visual alarm, where you'll see there'll be a red light going off, and you'll hear this buzzer kind of humming out like, hey, what in the world is that? Because I've had people call me like, do you hear this on the phone? I'm like, yeah, that's the alarm for your septic tank. They just had no idea what it was about because they've moved in off sewers and didn't know that system even had a pump tank on it. Okay, so to get into the lateral field itself, and this is kind of really the whole meat of the system. You've treated your wastewater, now we need to get rid of it and get it back into the groundwater, but make sure we've cleaned it up and taken it care of first. So some conventional lateral fields themselves, there are rock and pipe systems, there are leaching chambers, there's a mound system, which is a kind of an artificially created septic system that lies on top of the ground. There are lagoons, and then another one I'll have a slide on is a wetland cell where you're actually using plants and water thriving plants, like cattails, lilies, other things to clean up and remove some of those contaminants before it goes out to a conventional lateral field. Here's just a cross section of some leaching chambers and rock and pipe. A lot of the people, if they have older conventional systems like these, they will be made of rock and pipe. The system on the left is kind of a newer system with leaching chambers. The idea is that you're digging a lateral trench into the ground, and in this trench, you need to create a void where you can allow this wastewater effluent to sit and settle as it's slowly being absorbed into the ground. A lot of things back in the day where they would just do ring and pits, where they would dig a hole 8 to 10 feet in diameter and about 8 to 12 feet deep. Sometimes we'd call them clear wells or dry wells, but it's kind of the reverse aspect of a well. You're not taking groundwater from it, you're putting water into it. Where now we don't want those wells going straight down to the ground, because that concern was they were right on top of the groundwater and there wasn't that soil there to filter and clean up those contaminants. Where now the deepest the system can go by code is 24 inches. And that's the idea that we have to create this void underneath the surface of the ground, but fill it with rock or this leaching chamber system to give that void and allow that effluent to settle and give it some point to absorb into the ground over a period of time. Here's just a regular rock and pipe open system. You can see literally it's just a trench. This one is a 3-foot wide trench. There is a pipe that's installed 4 inches off the bottom of the trench that has some rock on it. Then 4 more inches of rock around the side, 4 inches on top. And before it's all said and done, that system will be covered with either straw, hay, or spun polyester fiber, some kind of barrier material to keep the cover soil that goes over it from washing and eroding into the ground itself. You don't want to put soil back into the ground. You want to keep this void, give that wastewater some porosity to be able to settle and work its way back in. This is the installation of some leaching chambers. It's just a different type of material. Instead of that rock and pipe and all the little spaces in between the rock, you have this large void. So basically that is just an arc. And if you were to take that end cap off down at the bottom of the screen or on the left side where that pipe comes in, it's literally just a semicircle that's hollow all the way through. So it's kind of like a tunnel, but you're adding this enormous amount of space to allow that effluent to set up and set in there and give that soil some time to absorb it. The concern being is, I tell some homeowners, it's about ins and outs. If you produce more wastewater than the ground can accept it, well, the path of least resistance becomes up. Some instance where you check people's water bills and they're using over 10,000 gallons of water, a month. And I'm like, well, no wonder you're having a problem. The ground can absorb it at the rate that you're using it. And that's the idea, is that this length of lateral field gives you that accommodation to allow that absorption to kind of take place and build up a storage area while you're continuing creating wastewater. This is a mound system. There's a couple of them here on the county. We try to avoid them if we can, just because they're kind of unsightly and people are like, yeah, I'm looking at this property and there's this random giant hill in my backyard. I'm like, yeah, that's actually your mound system. So we will do these in areas that have very poor soil characteristics. The idea is that instead of able to get something beneath the surface of the ground, you literally create it on the surface, on top of it. These are very expensive alternative systems. The idea being is that you literally need to haul in and bring in every bit of your lateral field as well. They're very great systems. They're a dose system because they have to have a pump tank because it's a pressurized system. So effluent is evenly distributed over that entire mound at any given point. The only concern being is you look out in your backyard and you're like, it looks like someone parked 3 Studebakers, bumper to bumper, and then just covered them with dirt. Because this is about 4 to 6 feet tall in height. Because I'll have some homeowners and they'll call for a drawing of their septic system. Like, oh, you have a mound system. They're like, what do you mean? I was like, look in your backyard. Is there kind of like a little plateau table that's just randomly by itself? They're like, oh yeah. I'm like, that's your septic system. That's your mound. Another one we have is a lagoon. I always joke, a lagoon is a pond that you don't fish or swim in. All of the idea is that you still have a conventional septic system with your tank collecting all of the solids, but your wastewater carries out into this large holding pond, which we call a lagoon. And the idea is that there's still beneficial bacteria and algae in that pond that will break down that effluent and kill those pathogens that get down that bioload. But then also the idea is you're using sunlight and ultraviolet light as a form of sanitization. So on the surface of the lagoon, that light will basically denature and kill all that bacteria on it. The only really kind of negative with the lagoon is it does take some space. There are some large setback distances for them. And again, it's a pond that you're not swimming in. Now, at some point, a lot of lagoons, they end up with more turtles and fish and frogs. How they got there, the fish is always an amazing one for me. I know it's the bird carrying the leaf with the egg on it and drops it in there. But they're great alternative systems. And again, in an area with very poor soil characteristics. I always kind of joke that people have a negative kind of connotation that, oh Lord, these lagoons are terrible. They're poo-poo ponds. Like, no, there's nothing like that that's going on in this lagoon. It all takes place back at the house in the tank. But installed correctly, a lagoon is really the one septic system that will theoretically last forever. All lateral fields are based on the premises of failure, that at some point that lateral field can no longer take on any more wastewater, that biomat has just developed and the porosity in the soil has just kind of maximized itself out and can't take on anything longer. Where when it comes to lagoon, there's only two things that contribute to the level of the water in that lagoon, and what goes down your drain and what rain falls into it. So if you have a larger parcel of land with very poor property, I'm definitely going to try and sell and convince you that a lagoon is going to be your best option. Another one we have, or last one we have, is the wetland cells. So you see the cross section of the house up there where you have your sewer coming out, going through your septic tank. And then instead of going straight to a lateral field, we basically create this small gravel bed that either has a clay liner or an actual rubber liner in it to hold wastewater in it. And you fill that wetland cell with a media, usually a pea gravel or some very fine washed limestone gravel. And the idea is that the gravel is there as a substrate to allow plants to go into. A lot of people, sometimes the fail thing, the go-to is cattails, but they'll plant it with cattails, then I'll come back in a year or two and the thing is literally just choked out with cattails. It's like, no, it's like a plant like one every square foot, because this thing is getting constant water. The only thing that's contributing to it's not growing out of control is in the winter times and the frost. They do have a little more maintenance because you have to plant them, you have to thin them out. But I think as far as an alternative system where you're trying to use more Mother Nature to your benefit, these systems are great. Those plants, they take up a lot of the wastewater, they're polishing and refining that effluent. And just the idea that you're using more green to really clean up your wastewater before it gets out to that drain field and that lateral line to be pushed back down into the ground. So the basics of just the distribution of your lateral field. So the box on the left with the 4 pipes coming out, that is an equal flow box. The one on the top right is a hillside distribution box. And again, the one on the bottom right is an equal flow. Sometimes you might see one of these in your backyard where you're like, there's this random square stepping stone nowhere near your patio or your garage or anywhere, but that could be because that the lateral field was not installed very deep and there wasn't enough, let's say, adequate cover soil that was placed over that D box. So you can see these lids on the surface in the ground sometimes. These are basically just access points where effluent will come into the box and then it's going to be, like I said, distributed out to the lateral lines themselves. And then in talking about the proper installation of it, you want to make sure that your boxes are not kind of having any kind of settling over time, because if the box gets out of level and then there's a line to the left and a line to the right, well, if the box gets a little uneven, everything could potentially start going to one line, and then you're losing all this potential absorption lateral field on the other side. It doesn't happen very frequently. It's more of a cause when you have an equal flow distribution box. Let me see if I can move one over. So yeah, so in this equal flow distribution, every one of those lines is essentially getting an equal part of that wastewater. Where if there's, in this one, if they're all 100-foot lines, as long as each lateral line is getting within 10% of the longest line, the equal amount, no one's working harder than the other. But if that box is not installed correctly, or if someone were to say drive over it and just settle that box a little bit out of level, well, it runs the risk that potentially one line is now doing the work of 7 of his buddies, where he's pulling everyone's weight and no one else's. So that's why it's just kind of being aware of where your septic system is, what kind of materials you're using, and make sure that you don't create a problem yourself over time. This is just showing a plastic distribution box that is equal flow as well. And then here's a cross section of a hillside distribution box where you have your inlet side coming in on the left, you have the outlets at the bottom going left and right out of the box, and then you have the overflow outlet on the other side. The idea being is, and I kind of tell people, it's like the champagne fountains where you have the glasses at the top and then glasses at the bottom, or even if you were to set up glasses on a staircase, you fill the glass at the top, and then that lateral line starts filling up, and then over time, just can't take any more. And then it would go back into this box, into the overflow pipe, and then down the hill to the next lateral line. And then so it starts working it all along. The idea being is that if you have a hillside distribution system like this, that the top line is what's taking first, and you're working your way down that hillside. And if or when you ever have a problem with your septic system, you're going to notice it at that lowest elevation line at the bottom of the hill. If you have a hillside system and say you've got a breakout halfway up the hill, but you know you have lateral lines beneath it, there's some kind of plumbing disconnection or distribution box issue. Just knowing on principles of how this works, you shouldn't have a failure up in the middle. It should always be down in the bottom. Now, if you have an equal flow distribution system, that can kind of happen everywhere. But ideally, if everything is equal, those lines should almost all but fail at the same time themselves. Now, you might get one breakout over here and then another one on another spot, but it's not like a conventional hillside system where it's going to be at the lowest point on the property. So to get into some prevention, some things that don't need to be flushed. I know there's a lot of things that are marketed as being flushable. I can flush my watch down the toilet, probably shouldn't do it, but just because I can doesn't mean I should. A lot of the big things like you can see on here, it's the grease, the sanitary napkins. I know baby wipes, or even they say now there's the flushable wipes. Those don't really break down. You're going to put them down your drain, but you're going to pay to have someone pump them out at another point in time. Anything that's plastics, none of that's going to break down. Another big one on here, like it says solvents, paints, and chemicals. With that being in mind, anything that's going to disrupt that bacteria in your septic tank is always a negative. I know people like to use bleach and heavy cleaners, and especially with COVID, you want to keep everything as sanitary as possible. The concern being is if you start pouring heavy amounts of any kind of metals or solvents and bleach down your drain, you're going to disrupt that natural bio load going on in the tank. Now you can always reactivate it again with those brewer's yeast and those types of things, but over a period of time, you don't want to keep knocking down those wastewater bugs in there because of overuse of chemicals and things like that. Another one which is kind of important is checking for leaky faucets and toilets. You might think that drip here and there isn't much, but over time it will add up. And there's no point in letting clean potable water go down your drain. If there's no contaminants to it, don't let it go down there. Kind of something I've taught people over time. If you're not aware that you have a leaking toilet, what you can do is take some food coloring, pour it in the top of your tank. And if your flap on your tank, or if you notice your tank is running, when you put that food coloring, over time, it will slowly work its way into the bowl of the tank. Again, it might not seem like much, but if you take that little bit and add it up over time, it's water that has no reason to go out to your lateral field. It's already cleaned. You don't want to waste it as it is. Keeping off your drain fields. This is a big one. A lot of people, again, don't know where their lateral field is, and all of a sudden, they're like, oh, hey, we're going to have some dirt or some gravel delivered on the property, and this huge triaxle truck with tons of weight drives through their lot, and then all of a sudden it collapses in this random spot on the ground. Oh, that's where your septic tank was. Unbeknownst to them, they didn't know where it was, but that's why trying to figure out what you have and where it is located on the property, making sure that you don't have to run the risk of any compaction is kind of the biggest thing. I always kind of talk about how lateral fields are like bubble wrap. And if you pop all the bubbles out of the bubble wrap, you have nowhere for that wastewater to go. You've smashed it all, you've compacted it. There's no more porosity for it to allow to go in. The grazing, the patios, the parking lots, roads, and buildings and swimming pools, those all have setback distance in them by code. Again, the main concern being compaction over those lateral field areas. Maintenance. So what they tell me to tell you all is that you're supposed to schedule and have your tank pumped about every 3 to 5 years. Ideally, if it's a new installation with a new tank, or it's just been pumped out, so you've purchased a house and you're like, oh, they had it pumped out when we moved in, I would give it 5 years. Wait 5 years, have your tank pumped out, and the pumper that's pumping your tank out, he or she can tell you, oh, hey, you didn't have that much sludge accumulation, you probably could have gone a little longer. Or they could say, oh, hey, your tank's really full of sludge and scum. You might need to be doing this sooner rather than later. Pumping your tank out every year is not really required unless you have a large family that is producing a lot of wastewater. Every 3 to 5 years is perfectly good, probably more on the 5-year level. But you can have somebody come out and check your tank to see it needs to be pumped. But again, if it's been more than 5 years, I would err on the side of caution and just go ahead and get your tank pumped out again. Lateral field maintenance. If you do have just grass over your lateral field, you do want to try and keep it short, but not too short. We don't want to scalp any lawns here. The idea is that you need that grass there, that, the fancy word of evapotranspiration, that grass will help draw up a portion of it, but you don't want knee-high or chest-high grass where if you ever go walking through your lawn in the middle of the late day and it's still been hot and your feet are soaping wet, you want that ground to dry out, not overly abundant where it's splitting and cracking, but you want to try and keep that system as dry as possible. Again, you are watering it from the ground up. So I'm sure many of you have seen, probably come in July and August, you get those nice green zebra stripes out in your yard, because again, it's wastewater that's underneath the ground. So the plants have something to thrive off on right above it itself. Looking for any kind of depressions or sunken areas where basically like over time your lateral field might settle. And then you've got these kind of like reverse molehills where instead of being above the ground, it's gone into the ground. Basically, you don't want any areas where there's rainwater or runoff that can pool and stand on that area. You want to try and keep a nice crown over your lateral field, so any rain or surface water coming towards it is diverted off and around, basically trying to keep this area as dry as you can, because you are artificially saturating it on your own. And then again, irrigation systems. You don't need to water the ground when you're already watering the ground that's there. I've had many people where they put in a lateral field and then the irrigation company comes in and they're like, oh yeah, we drug through some of these trenches putting in our drip lines. I'm like, why? It's already getting watered. You don't need a secondary source of water treating this area at the same time. Just trying to keep saturation levels at the minimum. So just going over some septic failures themselves, why they happen, what occurs. Basically the general sense of a failure is at some point the ground just can't take on any more wastewater because of just the age of the house. Again, that biomat developing over time. And usually what will happen is that, again, the pathogen resistance becomes up instead of down. That unless the system is installed very deep in the ground, which some systems were back in the day when that was allowable by code, the joke was the deeper you install it, the less likely it is to fail. That is true, but it could still have a subsurface failure that you're never aware of. Now, I understand a lot of people are not on wells and drinking water coming out of the ground anymore, but the idea being, say you slapped your septic system 6 feet down right on a rock bed and you had a creek that was in close proximity, you potentially run the risk of contaminating that creek because you don't have that soil there to filter out that wastewater. Sometimes I say failures that as long as it's not backing up into the house, the system is working, is true, but it's not necessarily always true. It does have a caveat that, just because mechanically that the system is functioning, you might not see the problem. And that's what the systems that are installed very deep into the ground can eventually have a problem with. If you ever notice that you're having really slow drains in the house, that could be because your system is installed really ground and it's creating more back pressure through the lateral field, through your tank and into your house, instead of the pressure coming out onto the ground itself. I will tell you though, if you have a basement with a shower in it, or if you don't have a basement, your shower is normally going to be your biggest culprit when it comes up to backups in the house. The shower, the drain is underneath your feet, the toilet drains at your knees, and the hand sink's up at your waist. Path least resistance is going to be into the shower. So basically you'll be taking a shower and you're like, wait a minute, why is none of the water draining out? That could be because that your lateral field has just become overtaxed. The groundwater has nowhere to escape, and it's now backing up into the house through your tank, through your plumbing, and up into the shower. So again, the main factors associated with failures, there's the age of the system, the improper maintenance, you were driving over the lateral field, you've compacted over your soil, the homeowner water usage, you're just, I tell people that they need to not be water conservative, but be water conscious. That if you're using all this water, don't do all your laundry on one day of the week. You do a small amount of laundry throughout the entire week, where you don't just wake up and say, oh, but it's Sunday, time to do laundry, and from 8 in the morning till 8 in the afternoon, you do laundry. Generating that much wastewater over that period of time really beats up and overtaxes your lateral field. So you're better off doing small amounts throughout the day. But again, if you need to do things, you're going to need to do things. But just be aware that consequences can happen from using too much water at a period of time. The fourth being the seasonal saturation by groundwater. We're hopefully getting out of the wet season once we can get out of April into May. Between the factors of rain, snow, perched water tables traveling up and down over time. Groundwater is kind of like the bane of my existence, because sometimes you'll see things that are there and then a spring can pop up and then it's found a path of least resistance to the lateral field and creates other problems for that system as well. So repairing the failing septic system. So this is kind of probably where we're all falling to here. Kind of the first step is you would just call the local health department. You get myself out there. You'd say, hey, Charlie, I've got this saturation spot out in the yard. It just never seems to dry up. It's always there. It has this foul odor kind of smell to it. basically to determine, yep, you have a system that is failing. This is in fact over one of your lateral lines, and confirm that yes, you'll need to start a repair for the system. And you can see down there in the bottom right, those green stripes, that's probably sometime in August or July when they're going through a drought, but you're watering your yard, so you'll get those nice green zebra stripes running through the yard. So continuing on with the repair, we'll basically come out there, do a site evaluation, look at the soil, its quality and characteristics, and see at what kind of depth the system can be installed, taking account the number of bedrooms to come up with an overall footage and linear length of what kind of system will need to be installed, and then generating a couple options of what can be done. And then from that, you'll take the evaluation, give it to the installer. The installer will apply for with the application for the evaluation to start the repair. The repair essentially is they've taken that site evaluation that I've generated and say, okay, of these 3 options, we're going to go with option number 2. So that way I know what the installer is going to be installing. So when I come out there to do a final inspection, I know what to expect to be looking at. So that way I can install that, yes, it was installed in the correct area at the right depth with the proper materials, and everything is finalized and correct. So some secondary structures. I know a lot of you, if you've just gotten pools or sheds or garages in the last couple of years, in the last 9 years I've been here, you've called me to get a release letter. The idea being is that I need to know that you know where your septic system is and you're not putting something too close to and or top of your lateral field. There have been instances where people have basically wanted pools and they went out to there and they're like, I want a pool and I want it right there. And no one's gotten a permit either through planning and zoning, or they didn't even come to me to find out where their septic system was located. And they literally excavate the pool in the middle of their lateral field. That is not a good thing that you want to be doing. I put the slide with the deck because it was kind of the joke back in the day. People would have their septic tanks about 10 feet off the back of their house. And then they put patios and decks over their tank thinking like, oh, well, I never need to get back in this thing. I'm like, well, yeah, you do. You have to pump that out every 3 or 5 years. So you need some access to that. The sheds and the garages is something we're kind of catching more today, where we have these building release letters through planning and zoning. That is, you don't want to mistakenly put something over top of your lateral field or your septic tank, potentially creating a public health concern for yourself in the future. And that's all I have. So I'm going to stop sharing. There we go.
Thanks, Charlie. And I thought we used to do this in an hour, but I guess we're just really excited to talk to you all. So we're being a little long-winded tonight. We'll wrap up soon. Just bear with us. A couple questions in the chat. How often should yeast, Ridex, etc., be used in your system?
Hold on. Sorry. Okay. Ideally, every time that you pump your tank out, I would say repopulate it with that. And again, I just threw some brewer's yeast in my tank this year when I had it pumped out. The other idea is that Ridex is more of an emulsifier, so that way it helps take those suspended solids. I kind of laugh whenever I see the Ridex commercial. I'm like, that's not going to prevent a septic tank failure. That tank is like collapse and overflow. That would not prevent that. But if you did it every couple of years, if you were able to check your tank and say, periodically that it didn't need to be pumped, but you wanted to keep kind of artificially creating those good bugs and that bacteria, still every like 3 to 5 years, I would dump a packet or 2 in there and just to help keep that bacteria going nice and strong. But again, every time you go to the bathroom and create waste yourself, there's almost 1 million bacteria colonies in your waste that's being generated. So unless you're doing something like taking a lot of antibiotics or using a lot of chemicals, your tank should be fine just on its own. But if it makes you feel better to pour some yeast and Ridex down the drain, by all means, go for it. Just don't go crazy with it, because you don't want a lot of off-gassing from all that yeast you're throwing in your tank to be creative as well.
Okay, I'm going to go up in the chat to make sure we get those questions, and we'll go back down. How can you find out the layout of your septic and lines?
Okay, so I'll just kind of jokingly show everyone. So if your house was built in 1990 or newer, ideally, fingers crossed, you are in one of those 5 cabinets there or the 3 cabinets in the hallway. If the system was installed at the point where the health department existed and that we took over the Onsite program in 89, 90, I'd say theoretically, I should have a drawing of your septic system here. I can all but guarantee you if it was done in the last 9 years, that means I did it. So I know you have a drawing and it looks better than something sketched on a napkin that usually kind of back in the day, colored pencils and crayons seemed popular for a period. So if anyone wanted to get a drawing, they can email me here at the health department. It's charliew.ward@ky.gov. That's charliew.ward@ky.gov. I would just need your address, and then I can look you up and see your lot number or your year your house was built, and ultimately determine if I have a drawing for you. Now, say I don't have a drawing for you, I can get you in list with some installers that can go out, probe, and locate your lateral field. Kind of like if you called 811, that before you dig, they're not going to come out and look for your septic system because this is a private septic system, so it's your responsibility. So you will have to hire someone to come out and find that lateral field for you. But again, if it's 90 or newer, theoretically, I should have a drawing on hand here in my office for you.
Great job for an intern to scan those someday.
We're already in talking about that.
Yay. Are there any actual restrictions on what you can plant in your septic area, or is it just those main recommendations?
I would stick to the main recommendations. The big no-nos are like river birch trees, sycamore trees, silver or water maples. Yes, the trees are great in that they're taking up that water, but also with that root infiltration, I have seen many water maples that get in that pipe that's in that lateral line, and it will literally loofah with roots all the way through that pipe, where you're basically pulling out these long, massive root balls that are growing through it. So yes, the trees are there taking up the wastewater, but the roots are also occupying that space that wastewater needs to reside in. I always get asked, people want to grow gardens over their lateral fields. I'm like, no, just fertilizing with manure and other animal waste is fine, but don't use human waste. It's too close to our own. The E. coli, the fecal coliform, like your tomatoes will be huge, but please, no, I'm not recommending you grow your garden over your lateral field. But if it was just some flowers or prairie things, that's totally fine itself. You just don't want to be doing any over cultivating or excavating over that area. You want that soil to be nice and tight, but not too tight that it can still, you want it to breathe. Again, you never want it to be compacted, but you don't want to be taking a tiller and loosening that soil, creating a kind of a conduit or a loose path. Like a big mistake people will make is they'll have fence posts put in. They don't know where their lateral field is, but all of a sudden we put this fence post in and it went through all this gravel, and I think there was a pipe in there. And well, like 2 weeks later, all this water started coming up around the post. You're like, well, yeah, you stuck a straw in your lateral field. And then the lateral field just started going right up the sides of the post and up and out of the ground. So the plants are great. Just watch the big trees. The shrubs are kind of like on the borderline of it. But if you wanted to keep like the wildflowers and things like that, those would be fine. Try to avoid like the really tall ornamental grasses, just because you do want some airflow over that field itself. You want it to dry out, but not be in a drought-like phase, but you don't want any kind of moisture being retained over that field. You want it to be able to breathe on its own over time.
Sounds like a great site for a selective pollinator garden. And we'll talk more about those plants. I'll send something out. I'm really getting into this. How much bleach is too much, or should you not use bleach in your laundry?
You can, if you feel like you're using an excessive amount, you probably are. I would say that, your normal cleaning, if you're doing your sink bowls or your tub, that's fine. But like if you go to clean your bathtub and you put the plunger down to fill up the water, and you literally just flip the top off the Clorox and you're just chugging it down, like that's probably too much. But if you are feeling like you're using an exorbitant amount of bleach, just get that Red X or that brewer's yeast and help repopulate that tank. Give it a day or two to allow that chlorine to kind of denature itself. But just be kind of aware, like if you feel like you're using a lot of Clorox and a lot of bleach, like you might want to supplement your tank with something else.
Okay. I feel like our septic system has a stronger smell than previously. It does have an aeration feature that comes on every 15 minutes. We had it pumped 2 years ago. Would this be something related to bacteria?
Potentially it is. If something has somehow changed where there's more people or you're adding more bioload into that tank, you could be producing more organisms and more nitrogen waste in that tank, and you can get some off-gassing that's from it. A lot of times what will happen is people will think that their septic tank or their lateral field is creating an odor, but there's no wetness or saturation. And what will happen is all plumbing is vented through the roof of your house, even your septic tank. Hence why those sanitary teas that's in there, yes, there's the liquid layer below the tea, but there's also the gas that's developing above the tea. And as that gas fills that tank, pressure eventually will push it back through that tea, up and then out the roof of the house. And you'll get this kind of wind effect where if the wind blows over the roof of the house, it will roll around. And sometimes you can get that smell of that off gassing, like, wait a minute, I can smell like wastewater, sewage. What is this? And it'll be just the natural venting of the plumbing in the house. Now you can, with an aeration system, have more of an odor be prevalent because you are agitating that tank. You are actively stirring it up. That's kind of the twofold is you're creating more beneficial oxygen, but you're also agitating it. So like think of, say, a stagnated pond where to stand there to look at it, you might not smell anything, but if you jump in it and you start churning it up and you release all that nitrogen out of the bottom of the pond, you're going to smell something. And that's because you've now agitated it and resuspended those solids into it. They do make some carbon filters where it's like a pad that you can install over the inside the lid of that tank to help trap some of those gases. They also do make them for the vents of your house on your plumbing stacks. Just if you notice it's a really bad odor, and sometimes it could be a relation because you just used a lot of water where no one's been home. It's now 6 o'clock and everyone's gotten home. Some people are taking showers from baseball games or volleyball practice, and your tank's been sitting stagnant all day, but then you just pushed a lot of water through it. Well, that water can agitate that tank, resuspend some of those solids, and potentially you can get an odor that will come from it. But if it's something where it's intermittent, is less of a worry than if it's something that's a chronic, constant problem. If it's always there, no matter when you get home or what time of day or the season of the year, if it's always there, is a little more of a concern than if it's something that kind of comes, lingers, and then just fades away.
And I'm going to share my screen so we can wrap up on overview of the program. And Charlie, can you put your email in the chat?
Right now.
Okay. So quick overview of how the septic system program works. So again, as Charlie spent a lot of time talking about, the purpose of wastewater treatment is to reduce the pollutants that can cause a danger to human health. They contaminate the groundwater, surface waters, and that's mostly due to that bacteria, which potentially has viruses, parasites, and as well as other toxic chemicals and anything you put down your drain, really, that's not treated, that ends up in our waterways. So this program, I call it this intergovernmental partnership because we have Oldham County Fiscal Court, that's my employer, and their whole idea is they want to support quality of life broadly. And then the Curry's Fork Watershed program, which is one of our big purposes of the program, is we want to decrease bacteria in the streams. And then you have Oldham County Fiscal Court, Oldham County Health Department, who wants to eliminate failing septic systems, and that is regulatory. So if you contact me and you tell me you have a failing septic system, I have no authority to do anything about it. But through this program, if a problem is identified, as in Charlie goes out, he identifies a program, now there is a responsibility to fix that program, and hopefully this funding and program will facilitate that for a lot of you. But ultimately, the goal between all of our groups here is this safe, clean waterways, and we work together to make this happen. A little bit about the funding for this. So I talked about Curry's Fork being a really unique program. The funding is also very unique. It's very rare for people to get funding to help them repair or replace their septic system. So I'm really happy we can provide this to people here in Oldham County, but just know that it is a really special program. So the funding for this, which is also the funding for my position and all the other work we do, comes through that EPA Clean Water Act, thinking back to the streams in the Curry's Fork Watershed not supporting the intent of safe, swimmable, fishable, aquatic life, all those good things we want to see in our streams. That funding gets funneled to the Kentucky Division of Water, and then through grants that we've applied for, Oldham County Fiscal Court now receives some of that funding, which is specific to this Curry's Fork Watershed program. So everything we do with this funding, there always has to be that education component. Education is really important, which is a big part of why we have this workshop here tonight. We also have these target areas, which I had mentioned previously, based on the watershed plan, based on where our septic systems are, where we're likely to have failing septic systems, and where we're going to have that biggest, hopefully that biggest water quality improvement in identifying areas that have failing septic systems, go in and fix them and be able to justify that area over a different area. Mention that education, so this workshop is required for funding. And then we have this cost share program component, and there is a prioritization. So we have our priority areas, and then among that, if you apply, I'm going to do a ranking of everybody that applies, and we're going to be looking at those priority areas. We're going to look at your lot size, your age of your system, and your proximity to streams. So this is a weighted system that we've come up with in order to be fair and ultimately have those biggest water quality improvements. This time with this funding, we're doing a 50-50 cost share. So our grant is going to pay 50% up to $7,000 for your system, and then you will pay 50% if your repairs are over $14,000 total, which is possible, then you will have to pay that difference between the $14,000 and whatever it is. So for example, say you have a $15,000 replacement that a contractor has given you a quote for. The grant will pay $7,000 and you will pay $8,000. And if you're not sure if you live in the Curry's Fork watershed, there is a easy-ish way to figure that out. The Oldham County Fiscal Court, they have their GIS online mapping system. There's this link here that I've put together. It's just a bit.ly/Oldham map. It's case sensitive, so that is all capitalized. And you can go into this mapper and click on the Curry's Fork watershed. We're going to send more on this as a follow-up later. But if you're really savvy on this stuff and you're not sure and you want to know right now, then go ahead. But you can see if you live in the Curry's Fork watershed, and then you can also see which of those sub-watersheds. So I had mentioned North Fork, Curry's Fork, South Fork, Curry's Fork, Asher's Run, and then the Curry's Fork main stem. And then in terms of our priority areas, so again, stemming from the watershed plan, the initial highest priority area is in this upper Asher's Run area. This was the target area for the previous septic system program that wrapped up in 2019, I want to say, maybe last year, but mostly wrapped up in 2019. And then this year for this program, we're also adding this like the Borwick Farms and all those other subdivisions. Now, this isn't to say that if you have a failing septic system and you are not in this area that you're not going to receive funding, but this is just the priority areas that we are starting with. So you have an understanding for how you're going to rank out, and you'll be contacted. We're going to have an application period. I'll do the ranking and I will let you know where you rank out in this. I expect this program to probably take a little while to come through, just to go through all the steps and actually get the repairs on the ground. So just be patient with us, and we'll work together. And if you're waiting and waiting and waiting, you can decide if you want to keep waiting and maybe get funding at some point. There will be a time where it probably doesn't make sense to wait anymore. This funding is limited. We have a set amount. And so just a lot of logistics and unknowns right now, but we'll all work through it. I'd mentioned those factors and prioritizing. And then Charlie talked about this, but to give kind of a look at this another way of the program steps, the roles, there's a lot here, nothing you need to memorize, but just understanding there is a whole process here that we went through in our last program. It worked really well. We're going to continue to use this. This is making sure that we are Like I am meeting all my requirements for my grant. We're complying with any laws, permits. We have a checks and balances in terms of where money is flowing. So there's a lot of really good reasoning for why we have this program laid out the way we do. But just understand that because there are a lot of steps, things will take a little bit more time. So on the left here, me as the watershed coordinator, I coordinate this program through Oldham County Fiscal Court. I'm going to accept your applications and rank those. Charlie, he's the go-to for any type of education and technical support related to the septic systems. And I'm going to give him the list of rankings, and as he's able to, he's going to connect with those with you based on the ranking in order from ranked highest priority to lowest, to get out and provide you an inspection if you haven't had one recently. And then if you have a problem, he's going to contact me and say, yep, they've got a problem. And then as long as we have funding left and you are interested, we'll roll you into the program. And then from there, you will need to get bids. We're working this out right now. We might do this a little bit different than we did last time, but through Oldham County Fiscal Court, we're required to have 3 bids on everything we do that's over $3,000. So we can't get away from that procedure. So we'll have to get 3 bids from approved contractors. And then typically we choose the lowest bid of those 3, unless there's some other reason why we would choose another one. Once that happens, you're going to submit your 50% payment. The work can get done. We can't do anything if you don't submit your payment yet, and we can only take checks. So you really need to make sure that you have that cash available in your bank account. And then once that work is done, Charlie's going to go inspect it. He's going to confirm with me that it's all done, and I'm going to initiate the process of just pushing those funds through where they need to go, getting that contractor paid, and you will be all set and hopefully happy with the outcome of this process. Okay, I just wanted to show the results of the previous program that we did. So as I said, we focused on this upper Asher's Run subwatershed here. So most of the work was really concentrated in that area. Ideally, we would have work concentrated in areas because that's really where you get the biggest water quality improvements, as opposed to having systems repaired scattered about the watershed, but that might not make sense for this. So we're finding that balance, and it's just going to depend on who shows up for these workshops and who submits applications. But I guess part of this too is that through my job, through the grants that we receive for this, I have to do a lot of documentation. So if it seems like I'm asking a lot from you to give me information, just understand that it all has, it's all for a purpose and for a reason. And part of it's what we have to do, and part of it's because I want to celebrate this work that's going on and share it and educate people and make people aware of septic systems and how they work. So here is the link to the homeowner application. Again, we'll send this out later. If you are interested in submitting an application to determine if you're eligible for the next parts of this, you need to submit that by May 14th. This is a Google form. If you would prefer this in a paper form, then you can contact me and I will either email or mail you the paper form, and that will be fine too. So multiple ways to get this application submitted, and you have quite a bit of time now, but we do need to have a cutoff so we can start to rank applications. Let's see. All right, that's the last slide. Now I'm gonna do the pump out giveaway, but I wanted to stop in case there's any questions. And I know I didn't allow time for questions earlier, so I'll check the chat real quick. And then Charlie, if I missed anything or you think something should be clarified, go for it.
So I'll just tell everyone the good news, bad news is the good news for me is I'm having a son born in 2 weeks, which is kind of bad news for everyone here. But I will be, hopefully the process that I'm on paternity leave, I think I said that right, paternity, not maternity, paternity leave. Becca will be going through and categorizing everyone through the cohort system of kind of that structured layer. Think of it as a bullseye. We want to target the bullseye, and once we hit the bullseye, then we can move to the ring outside the bullseye, and then the ring outside the bullseye. But that's just me getting in the field while dealing with vaccination clinics 2 to 3 days a week and having another child again. So if the process seems like it's going a little slowly, it's because we're pushing like a 10,000 pound stone ball to get it rolling. And once it's rolling, we'll get it rolling. If you're on the list, I promise you, I will get to you. Even if you feel like you don't have a problem, but you'd like me to come out, by all means, I can still come to your property. I'll walk through and answer any questions you all have. Other than field work and keeping public safe, education and information is a huge role that I have here at the health department. I feel like that's, if anything, my main role is just, I'm a public servant. You all have questions. I'm here to hopefully have answers and solve problems for you all as well. Hopefully not everybody has a problem, but I can help confirm with you whether you do or don't, just so that way reassurance that you know, I'm not sure, but I can help come out there and determine whether you really do or don't. So that being said, hopefully I will take off for 3 weeks. I won't be dropping off the face of the earth, but I will be kind of somewhat unavailable. So hopefully by the end of May, I will come back to the program, hit the ground running with my list of who I need to go see. And then literally once I'm out there, that next day, theoretically, you'll have for me what you'll need to get to those 3 installers to get those quotes. So I'm gonna say it might be kind of like a wait, and then it's okay, here it comes, and now we're ready to go through it. Now, as far as the installation of the system, that's not going to happen as quickly as me getting out there to determine what you're going to be needing. Everyone's still installing systems. Housing market's going crazy. A lot of work is happening. They will get to you, and as long as we know that the work is scheduled to be done at a point, you will have it done. It will happen, but it won't be the same week. It probably won't even be 2 weeks. We'll be lucky if it's even within the same month. But that's just because things are going like gangbusters right now, and everyone's swamped and covered with work as it's going. So just be patient with me. I will get to you. We will get what you need. If you have a problem, we will ultimately help you and try and get it solved if we can.
Yeah, and I put the form up, shared my screen again and put the form up. I guess in terms of flexibility, again, we're just human. I do work part-time, so if I seem unresponsive, then that's probably at least part of it. And I put my email. Email is best for me as I am still going back and forth between working from home and my office. But we will definitely keep you updated and reach out if you feel like you're not hearing from us or you have questions. If you don't know the age of your system, I guess I would say ask Charlie to see if he can find that information.
And I think Karen and Chet have already sent you an email in response to your question.
Okay.
But yeah, anyone that's here, by all means, if you don't know when your house was built, just give me your address, email it to me. I can look it up and say, yep, I either do something or no, I don't. Just give me some time. Tomorrow's a vaccination clinic that starts at 9 in the morning that goes until probably 2 or 3. So it won't be first thing in the morning because I'll be outside assisting registration. So just give me a day. I'll try and get everyone that asked for one. I'll try and get their information to them hopefully by then tomorrow.
Great. Yeah, and I've created the form. So if you don't know, you're able to provide kind of a short answer for a guess or approximation or something like that. Don't worry too much about the weighted system and the ranking. It's all going to kind of come out together, and we'll figure that out. So don't worry too much if you don't know on that. Okay. If there's no other questions, I'm going to move on to the pump out. Oh, let's see. One more question. If we're in the process of getting bids, do we need to stick to the list of 5 that Charlie recommended? I just need 3 bids from certified contractors. So I would assume that Charlie would have sent you the list of certified contractors, and probably all 5 of those were. So you don't need to stick to that list, but they do need to be certified contractors, and we do have a list. I guess that's something we can talk about later. Okay. So this is for our septic system pump out. I see a lot of you got pump outs recently, which I applaud you on. So if your name comes up and you don't need one, I I guess I'm going to do 2 names to begin with. This might be a little finicky, but I'll do 2 names to begin with. And then I'm going to do 4 more names. And rather than wait for you to respond on if you need it or not, I just want it to be fair and you could transparent so you see what's going on. So I'll touch base with the winners later, or I can stay on tonight for as long as you want. But I know we're trying to get going. So I'll draw 2 names, then I'll draw 4 more as, I guess, backups if those 2 don't work. And then I'll just be in touch with everybody to